I'm Anil Kumar, and in this particular video, I'm treating this as part 2 of data analysis and sampling techniques. In part 1, we discussed solution of this question from the previous test paper. The question is, a teacher surveyed his students. He asked them, on a scale of 0 to 12 hours per week inclusive, how often do you do your math homework? Their responses are shown in the table, right? Now, one portion of this was also, what portion of the students did an acceptable amount of homework if the teacher believes a student should do at least 1 hour per school day? So per week it becomes 5 hours, correct? Now what I did was that I copied the data and more or less the question here for you. And in part 2, we are discussing how to convert this discrete data into grouped data. So first step is that 0 was identified as an outlier. To convert it into a grouped format, we have to remove the outliers. That is always the first step, as mentioned here in this particular question. So it says remove outliers to allow for grouped format. This is very important. Always, if you are given discrete data and you want to group it, in that case, you have to remove the outliers first and then analyze. So after removing this, we'll make frequency table, histogram, and then frequency polygon. So let's begin by making the frequency table. So what I will do here is we'll just count the number of hours, how many times it appears. So in this column, we'll have number of hours per week, and then we write frequency here. This data represents number of hours students work at home per week, right? We have already taken care of outlier by removing it. So we have total 53 students response here. So if I write 1, number of ones are, let's count them. So we have 1 as 1, 2, 3, 4. So we have 4 ones. Let's see how many 2s we have. So number of 2s here are 1, 2, 3, and 1, 4. Number of 3s, 1, 2, 3. There are 3 3s. Number of 4s, we have 1, 2, 3, 4, 5, 6, 7, 8. Number of 5s, we have 1, 2, 3, 4, 4 5s. Number of 6, 1, 2, 3, 4, 5, 6, 7, 7, 6. Number of 7s, we have 1, 2, 3, 4. Number of 8s, 1, 2, 3, 4, 5. Number of 9s, 1, 2, 3, 4, 5. Number of 10s, 1, 2, 3, 4, and 1, 5. Number of 11s, 1, 2. and number of 12s, we have 1 and 1, 2. So that's the data. So we have made a frequency or a tally chart. For each number of hours, we know how many are there. Now, from here, we can actually group them. So what kind of groups do we take? We could take a group with interval of 3, since there are 12 number of elements. So if you divide by, let us say 5, you get 2.5. So it is good to have at least 3-4 intervals to analyze the data, right? So basically what we saw here is we have a range which is from 12 to 1, which is 12 minus 1. So there are 12 elements basically. Let's say 11. And if I divide this by, let's say 5, I get 2 point something. So I should have interval of, let's say 2 or 3. So we'll take interval of 3 here. So we'll make another column with interval or class. So we can say class interval. Okay. Now to make a discrete data as continuous, it is good practice to use 0.5 so that all these elements can be taken care of. So we could have interval of from 0.5 to 3.5. That gives me the class interval of 3, right? And so we could now make it like 3.5 to 6.5, and then 6.5 to 9.5, 9.5 to 12.5. So that takes care of all the elements which we have. Let's count. In each, how many are there? So that first group is basically from 0.5 to 3.5. So that is our first group. Then up to 6.5, and then these are the groups. So if I count these, 4, 4, 8 plus 3, 11. So we have 11 here. In the next one, we have 12 and 7, 19. And then we have 10 plus 4 as 14. And in the last group, we have 5 plus 4, 9. So that becomes the frequency for the group data. Is that okay? That becomes the frequency of the group data. Let's take the midpoints to draw the histogram. So the midpoints, let's call them as xi. The midpoints, say let's midpoints, mid value. So mid values, add them, divide by 2. So we get mid value of 2, and each increase by 3. So we get 5 plus 3, 8 plus 3, 11. So that becomes the mid value. Once we have the mid value, we can actually create the histogram. Perfect. So let's do histogram now. So I'll use the space to create the histogram. Or we can make it here also. Okay, let's do it here. So let's create the histogram here. I'll use this line. Now in the histogram, we are looking for representing data up to 11. So let's go by multiples of 5. Okay, so let it be, we can go with 2s. So it is, so we have 2, 4, 6, 8, 10, 12. Correct. Now we should break our scale, and we can begin with the lowest point, which is 0.5. Okay? And at equal intervals, we'll have 3.5, 6.5, 9.5, and 12.5. Correct? Now we can create bars which are continuous. For example, 0.5 to 3.5 frequency is 11. So this is like 2, 4, 6, 8, 10, 12. Actually, it goes to 19. I'll have to actually extend it. Okay, 14, 16, 18, 20. Okay, so let's write. We have 14, 16, 18, 20, right? So for each group, we are looking now at these two columns. 11. So from this, we have 11, that is between 10 and 12. Correct? So now we can make this vertical lines for the bars. There it goes. So that becomes 1. Now 3.5 to 6.5, it is 19. So 19 is kind of here, so we can go up, extend, 19. Then we have 14. So 14 is right there. So assume their widths are same, right? It doesn't look like, but their widths have to be exactly same. Perfect. Okay. And last is 9. So 9 is kind of here. So we'll just extend this. 9. So that becomes the histogram. So what we have done here is produce the histogram for the given data, right? So histogram represents this class interval with each frequency. Now to make a frequency polygon, we look at the middle value, which is 2, 5, 8, and 11. So these are your middle values, 2, 5, 8, and 11. And joining them, we get our frequency polygon, right? So this is what gives you a frequency polygon. So when you work with continuous data, that line has to be a solid line. So earlier when we were working with discrete data, we made a dotted line. Perfect. So this becomes our frequency polygon. Right? Now, in the next part of this video, we will see how to create a cumulative frequency graph from this given data. So now we'll look into how to create a cumulative frequency graph of the given data. So it's exactly the same data for us, right? Cumulative frequency graph is also known as Ogive curves. So the data which we have, let me reproduce it here. So what we found was that, let me write down the frequencies for the intervals we worked on: 0.5 to 3.5, 3.5 to 6.5, 6.5 to 9.5, and 9.5 to 12.5. The frequencies were 11, 19, 14, and 11, 19, 14, and 9, right? So those were the frequencies. That is our class interval. Now to find the cumulative frequency, it actually means that here we are looking for the elements which are less than 3.5. So everything, so what are we saying is everything which is less than 3.5, correct? So that is less than equal to, let me say less than equal to 3.5. And then we'll say what is less than equal to 6.5, what is less than equals to 9.5, and what is less than equals to 12.5, correct? So clearly, less than equals to 3.5 is 11. Less than equals to 6.5 will be add them up, correct? So add them up. So it is 19 plus 120 plus 10, 30. Add 14 for the next. So it is 44. and 44 plus 9 is 53. So we know there are total elements of 53 since we excluded 0, which was an outlier. Correct? So that becomes the cumulative frequency. And now let us see how to sketch the graph of cumulative frequency when we are working with grouped data. So to begin with, let's break the scale. We are working from 0.5, and then let's say this is 3.5, and then we have 6.5, and then we have 9.5, and then we have 12.5, right? So we are going up to 50. Let me just sketch in tens. So I'm making a rough scale here. 10, 20, 30, 40, 50, and 10, 60. Now, less than 0.5 will be 0. So the first point here is always the beginning, right? So less than 0.5 is actually 0. This is important, not to be missed. Then at 3.5, we have 11. So since this is 10 for us, so we'll take a number which is slightly higher than this, right? And then at 6.5, cumulative frequency is 30. So this is our 10. This is 20, 30, 40, 50, and 60. So at 6.5, it is 30. So we'll go up. That is the value. At 9.5, we're looking at 44. So we'll again go up. 44 is midway right here. And then at 12.5, we're looking at 53. So we'll go up 50 and slightly over. Correct? And then we can join them, kind of straight lines, which indicate the slope. You see that? So that becomes the cumulative frequency for the grouped data. Correct? So the last point here is, let me write down 53. So that is how you sketch the cumulative frequency graph for the grouped data, right? So that is how it is to be done. So I hope the concept is clear. All these numbers come at the end of the interval, not in the middle of the interval, right? As we seen frequency polygons earlier when we have done. So this is our cumulative frequency graph. Cumulative frequency graphs can be used to find the average value. At times we can find quartiles, right? Q1 is like 25% of data. Q2 represents 50%. Q3 may represent 75% of the data, right? So you can find Q1, Q2, Q3 from the frequency. So I hope with this example, you understand very clearly how to convert a discrete data in a form which could be used to analyze as a group data. Now this is very important, especially if you have a lot of data elements to work with. Key is remove the outliers and then work with the rest of the data. Perfect. So 0 was an outlier which we removed, and then we decided on the class interval based on the range of the data. Since the range was 12, we just took class interval of 3. To make it continuous, for each point, we went to one decimal place. So 0.5 to 3.5, and then interval of 3 gave us the required classes. Under each class, we found the frequency, cumulative frequency, and then sketched the cumulative frequency curve. Now this cumulative frequency curve can be utilized to find quartiles and further analysis of the data. I hope you enjoyed this journey, understood the whole process, how we could use data. So data analysis and sampling techniques has been covered in these two parts. Feel free to post your questions. And if you like and subscribe my videos, that would be great. Thank you and all the best.